we want to look at another example of given a function, how we can find its graph. Now, again, remember we're doing an interpretation of that graph. I'm not doing exact points. Eventually you should actually go back and find the actual points, but I want to be able to demonstrate what you can do just based on these 5 steps. So I need to figure out the leading coefficient test. That's the very first one. So the first thing I've got to do is I've got to figure out what n is. What is my exponent? So if we remember, this one is kind of like another one that we did. I'm going to rewrite it here again real quick so that we can apply what we learned before and refresh if you didn't watch that video. So what I did is this term right here is raised to a 2. This is just x to the first. I add these two together and that's going to give me n. So n equals 3, which is odd. And then I need to go in and I need to look at the leading coefficient. So my leading coefficient is a 2, so I have a positive coefficient. Now that's great. So what does all that tell me? Well, if it's odd and it has a positive coefficient, it's going to fall to the left and it's going to rise to the right. So there we go again. We've already got a kind of an idea of what this graph is going to look like. Now I need to find the x-intercepts. And so in order to find the x-intercepts, remember you're going to set y equal to 0. So I'm going to have 0 equals 2 times x plus 2 squared times x minus 3. We can divide through by that 2 so that it's easier, or it appears to be easier to actually solve this. And then I'm going to set each one of those terms equal to 0 and solve. So I'm going to get x equals -2 and x equals 3. So those are going to be my x-intercepts. Now, what about the y-intercepts? Well, I need to set x equal to 0. So I'm going to have y equals 2 times 0 plus 2 squared times 0 minus 3. So I'm going to get y equals 2 times 2 squared is 4 times minus 3. So I've got 8 times minus 3, so it's going to be minus 24. So my y-intercept is at minus 24. So we found our x-intercepts and our y-intercepts. So now what we need to do is we need to know if there's any symmetry with this graph. So when we look at that, remember we're going to plug in minus x everywhere there's an x. So I'm going to have f of minus x equals 2 times minus x plus 2 squared times minus x minus 3. Oh, looks kind of like a hot mess, doesn't it? So we would have to expand this term. So I would get minus x times a minus x is going to be an x squared. And then I'm going to have minus 4x plus 4 times minus x minus 3. The more I do this, I know I'm getting farther and farther away from what I started with, correct? So you can keep multiplying, but you're going to find that it's not going to equal f of x. And it's not going to equal the opposite of that, right? Because if I take out the opposite sign, it's still going to have pluses and minuses. So on this one, we're going to have no symmetry. Now what about the turning points? Well, originally over here I said that n equals 3, so I'm going to take 3 minus 1, so I'm going to have 2 turning points. So what does that do for us with the graph? Well, I've got the graph down here at the bottom, and we need to find our intercepts first. So we said that our x-intercepts were at minus 2 and at 3. And then I've got y is at minus 24. So in that case, I'm going to say that each one of these lines is 12. So I'm going to make this the minus 24. Now, according to what we got in number 1, we know that it falls on the left and it rises on the right, and there's 2 turns. So I would have it come to this point. There's my 1, 2. So that is basically what your graph would look like.